Hello students. So from today we will start from where I have left yesterday. I will start from the relation between your start coulomb and coulomb I have done, and I will start from the relation between coulomb and half coulomb. So let's start from that. That is our relation between coulomb and half sorry coulomb. Okay. Let me erase it first. Okay, and half column. So what is our definition of force in EMU system of units? That is F is equal to BQV sin theta, isn't it? Yes. Then Q is F magnitude divided by BV sin theta, where F is 1 Newton and sorry, what is it? 1 Newton, and your B is 1 Tesla into 1 meter per second into sine 91. So it is 1 Newton is 10 to the power 5 dyne, isn't it? Yes. 1 Tesla is 10 to the power 4 Gauss into 1 meter per second is 10 to the power 2 centimeter per second, isn't it? In CGS, and sine 90 is 1, obviously. So what will it become? 1 by 10. If you do calculations, you will get 1 by 10 your half coulomb. So 1 coulomb is how many half coulomb? 1 by 10 half coulomb. Okay. So this is your relation between coulomb and half coulomb. So let's see some few important points about Coulomb's law. Okay. Some important points are characteristics characteristics of Coulomb's law. Let's look into it. First of all, Coulomb's law, it is an experimental law. It is an experimental law. Secondly, it is strictly valid. It is strictly valid for point charges only. Okay. And the third point is Coulomb's force is a central force. It is a central force. It is a central force. Fourth point, it is conservative in nature. It is conservative in nature. Fifth point, for similar charges, Coulomb's force is repulsive, and for opposite charges, Coulomb's force is what? Attractive. For similar charges, sorry, force is repulsive, and for opposite charges Coulomb force is attractive. These are few points you have to remember about Coulomb's law. So let's move to our next point, that is vector form of Coulomb's law. How we represent vectorically, how we prove vectorically Coulomb's law. Okay, let's start with vector. Sometimes in your exam, direct question comes from vector form of Coulomb's law. What happened? Sorry. What is it? Yes. Yeah. Vector form of Coulomb's law. Let me use another. Okay. Let's start. For this, you have to consider few points. Okay. So let F12 is the force acting on charge Q1 due to charge Q2, and F21 force acting on charge Q2 due to charge Q1. Okay, and position vector R12 is position vector from charge Q1 to charge Q2. Similarly, R21 is position vector from charge Q2 to charge Q1. Okay. So let's see what's next. What we have? We have two cases. I will discuss the cases one by one. Case 1 is when two charges are similar in nature. When two charges are similar in nature. Okay. Two charges in similar in nature means we have Q1, Q2 greater than is equal to 0. Okay. Here is Q1 and here is our Q2. And the distance between, if I also vectorically, then I will have to show it in position vector form, that is R12 here from 1 to 2 and here R21. Okay. The force acting on charge Q1 due to charge Q2, that is force acting on charge Q1 due to charge Q2 is F12, and force acting on charge Q2 due to charge Q1 is your force 2R, F21. Okay. So what is the if I will show the expression for force F12, what it will be? Let's suppose 1 by 4 pi epsilon I have taken beta Q1 Q2 divided by R12. 1 2 this is force acting on charge Q1 due to charge Q2. So From Q2, I have position vector R21, not R12. Okay. So I will have to write here R21, position vector R21. Remember this, a little change, and R21 cap. And what is the expression for F21? Beta Q1 Q2 R12 position vector magnitude R12 cap, the detection vector. Okay, is it clear to everyone? Okay. I can also write it as 1 by 4 5 epsilon naught if I am considering the free space Q1 Q2 divided by R21 cube R21 vector. Okay, is it understood to you? 1 by 4 5 epsilon naught Q1 Q2 R12 cube R12 vector. Okay. Similarly for F21 I have written this. You see here, if I will write the position vector, the distance between q1 and q2 are same, so the magnitude is same but direction is opposite, so I will have to write it as minus of r21. If I want to write it like this, then I can write f12 as what, 1 by 4 5 epsilon naught q1 q2. In place of R21, I can write as R12. If I will write R12, then I will have to take a negative sign outside and I will have to write it like this, isn't it? And I have this expression as, 1 by 4 pi epsilon naught Q1 Q2 divided by R1 or a Q R12 vector. So I can write it as F12 is negative of F21. So what is the conclusion you are getting from here? It is clear that both the charges will exert equal force upon each other but in opposite direction. Equal force on each other, equal force on each other but in opposite direction. Okay, I think it will be clear to all of you. Okay, fine. Let me, okay, sorry for the disturbance. Let's start. Okay, yes. So case 2 I have, when case 2 I have, in first case I have discussed about when the charges are similar in nature. In case 2 I will have to take the case of when two charges are opposite in nature. When two charges are opposite in nature. What happens when two charges are opposite in nature? Let us see. Opposite in nature, so we can write it as q1 q2 is less than 0, isn't it? Yes. Okay, so let me draw the diagrams for you. This one is q1, this is q2. Both charges are opposite in nature, means if it is positive then it is negative. And the position vector, this one is r12, this one is r21. Okay, and let's give it a point A and B, and the force acting between the centers are F12, F21. Force acting on charge Q2 due to charge Q1. Okay. If you will solve this, you will get in the similar process. I am not doing this because it's taking little time, but if you do the same thing, you will get final conclusion, that is F12 will be equal to F21. It doesn't matter if the charges are opposite in nature or the charges are similar in nature. always the force between them is opposite in nature, and it is equal in magnitude. Okay. Another important point here you will have to note down is Coulomb's law in position vector form. For your better understanding, I will do this Coulomb's law in position vector form. Okay, let's start this. Let me draw the coordinate system. Okay, this one is x, this one is y, this one is z. Okay, let me take in the coordinates. I am taking q1 and q2 at point A and B, and I am drawing the position vector with respect to the origin. Okay, this one is your r1 vector, this one is your r2 vector, and force acting on the q1 is F12, force acting on q2 is force F21. Okay, and the distance between them also in vectorially r21 and here r12. Okay, I hope it is clear to all of you. I have taken a 3D Cartesian systems, and in that I have shown this. Okay, if I will have to write the resultant position vector r21 or r12, how I will write r1 minus r2 in the coordinate system? You can write it. So f12, how I will show it? 1 by 4 pi epsilon naught q1 q2 divided by r. Remember the expression we have derived just few minutes ago, that is r12. I have written it as r21 and r12. If I will write it as r1 minus r2 in position vector form, because we are doing it for position vector form, and r1 minus r2 vector, it is the thing. And f21 similarly 1 by 4 pi epsilon naught q1 q2 divided by r2 minus r1 cube r2 minus r1 vector, isn't it? Okay, we are getting the force in terms of position vectors. Again you can see f12, again you can see from here also f12 is equal to negative of f21. Okay, okay, fine. Let us see one important concept from here, that is principle of superposition. You have to remember the definition for 2 marks or 1 mark questions, that is principle of superposition. I will write the definitions of this principle of superposition, that is forces between multiple charges. So what does it says? According to principle of superposition, principle of superposition, total force, total force, total force on any charge, on any charge, total force on any charge due to a number of other charges, at rest is the vector sum of all the forces on that charge due to other charges. Due to other charges taken one at a time. One at a time. The forces due to individual charge charges are unaffected by the presence of other charges. Affected by the presence of other charges. Okay, this is your principle of superposition. You have to just remember the definition. The proofs I will do in the later section. Okay, so for now we will see another important concept, that is your charge distribution. Charge distribution. There are three types of charge distribution. One is your linear charge distribution, another is your surface charge distribution, and the third one is your volume charge distribution. Linear charge distribution. Linear charge distribution. We denote the linear charge distribution as lambda, and we represent it as q total charge divided by the length, that is your r or s, whatever you can take. And the second one is your surface charge density. Surface charge density or surface charge distribution, surface charge distribution. Surface charge distribution, we show it as sigma is equal to q divided by surface area, that is s or a, whatever you can write. The third one is your volume charge distribution. Volume charge distribution, we denote it as rho. We denote it as rho is equal to total charge q divided by volume enclosed by that charge. This one is third point. So for now I will have to stop till this, and in my upcoming videos I will be showing the next chapters.